I don't know where that come from. It almost looks like something's gone through it. A little piece of plastic.
Hi guys, Fraser from Lifco Hydraulics. We have a PVP unit. So this is a Parker unit. It's about 33 cc, so it's a small one. And the customer complaint is that this pump is drawing too much amperage from this electric motor. So it's stalling the electric motor. Let's take a look to see if we can figure out what's going on.
PVP 3330, 33 cc's, preset for 3000 psi.
That's actually just saying that the range is 3000 psi, that it can go from 500 up to 3000. Where it's actually set, they'd have to determine that on the test bench.
They say the pumps normally last a year and a half. This one started to fail after a year. It's a remote comp. They say it's overdrawing the electric motor. Remote comp's only going to go to where it's told to go.
Now, why would a hydraulic pump stall an electric motor? What it means is it's asking too much from the electric motor. It could be doing it for a few reasons. The draw or the torque required is the pressure times the flow plus a constant, meaning that if that constant changes, let's say some parts seize inside of it, then it could be drawing too much. If they're asking for too much pressure or flow at the same time, that could also do it.
And if you could guess what happened before you open it?
I'm expecting to see some heat damage inside because if they're overamping the electric motor, they're probably running this at maximum pressure.
The high pressure with the sort of heating up, that's actually a mistake I made in a previous video, and I was corrected by one of my engineers. I'm going to make a post about what I learned on that one.
If you run at that maximum pressure, if you're overamping it, it's going to cause a lot of issues. I don't know if this is from shipping or what that's from, but like I was saying, it's a remote. The remote's only going to go to where it's told to go. So if your signal pressure is telling it to go to 5,000 psi, it'll go to 5,000 or over relief or blow itself up. If this is plugged, it'll act like a regular omit comp. So if this is set for 36, it's going to go to 36 regardless. You can feel some grooves. These little ones can be a little bit harder to feel the belling because they're so small, right? No pull off. I don't feel any belling. A real sharp edge is usually indication of it being hammered down. This has kind of a broken edge, kind of rounded, which is
like from factory, like naturally. Yeah. Okay.
Well, you can see some wear marks in it. It almost looks like something's gone through it. Maybe some contamination. So it could also be overamping if it's trying to put out full flow, but if you have too much case flow, it could cause it to pump to run hot.
This pump is pumping for the hydraulic system, but it's also pumping for the leakage, meaning the stuff that's not going into the system. It's coming out of the case drain. So, but the pump, the compensator, it only knows about what's in the system. It doesn't know about all this oil that's going out of the case drain. Let's say you have 1 gallon a minute going out the case drain, and then something happens to the pump. There's some failure inside, and it becomes 2 gallons a minute coming out of the pump, out of the case drain. That means that now this pump needs to pump an entire extra gallon. It needs to draw the amperage to do that.
Shaft looks good. No rolls, no brakes. Creep plate feels pretty good.
Is that normal to have color in there?
I don't feel anything. It's just a stain almost.
The color.
Yeah. They say that they only run them for about 18 months. This one only got a couple of months.
How long should a pump last? It usually comes down to the bearings. 10,000 hours is a good guideline. There are some extremely high longevity type pumps like the Gold Cup, where you can see 25,000 hours. That means that if they're running 24/7, it should be at about 14 months of running.
So unless we pull it apart and we see like a broken spring or something.
Yeah, like something obvious.
Spool's free. A little piece of plastic.
That seems like the same stuff that was on top of the...
Exactly. I don't know if that's from the shipping. It's just like a paper or something.
Would something like that little tiny plastic thing make a difference?
A speck of dirt, half the thickness of a human hair, can cause damage in a system.
Okay.
That don't look too bad.
What's that piece called again?
We call it the cone.
Cone.
And I don't feel a whole lot of wear on here. I'll do a quick lap on these to show if they're going to clean up at all, but they're pretty bad. You can see where it's making contact is all the grayer parts,
Oh, yeah.
and the shiny parts are where it's low. Pretty worn. And you can see that on the port plate, all the damage was on the pressure side, so it looks like there may have been something in the system, and when it was pushed out under pressure, it's what tore all the chunks off. But it could have came through the suction out of their tank, through the pump, through the case.
We wouldn't see it if it was still in the pump.
Unless you find chunks of metal floating around the case,
Yeah.
all we have is the damage done to it, right? So, but for the average person who looks at damage, they don't know if it's cavitation, aeration, contamination, dry startup, poor inlet condition, or implosion, explosion, technical terms. It's pretty deep. I know it doesn't look like much, but a thou or two.
Yep.
By the time we try to lap it out, we take half the life off of it. You can see all the pitting.
No lapping's gonna fix that.
No.
Those need to be replaced.
This may still work, but it's going to be very inefficient, create a lot of heat, and not work properly. So it'd just be counterproductive to try to even use it. Same with that. Like, pistons are probably reusable. Creep plate's good.
You'll do your measurements on those?
I'm replacing this, replace those. It's not worth taking the chance of having a couple of thou out. So there's not any evidence of a poor inlet or case problem, because if there is, when this is pounding, these pins will actually wear holes in here. Creep plate feels good, which is to be expected because the pistons aren't bad. New bearing, seal kit, and control upon testing.
Let's say you have a bucket, and the bucket has a line halfway through, and it says to fill to this line. But you got to walk across this field to there, and the water's all sloshing all over the place. But you need to get half of that bucket over to the other end. If the water's all sloshing over there, that means that you need to fill the bucket up 3/4 of the way full. And if you're really messy with it, if it's really inefficient, you're going to have to fill it up all the way to try to get that half bucket towards the end. Meaning that this bucket now is twice as heavy as it was. It requires twice as much energy to move that bucket across the field, because half of it is going some elsewhere. Where it's going is, it's going through the case drain. It's saying, I only need half of the energy here. If you give me more, it's a waste. But to get them that half energy, you got to fill this bucket up more and more and more as you get sloppier and more inefficient.
That could be the cause why it failed prematurely. If they're already having failures every 18 months, maybe something got into the system. It could be from a hose being moved. It could be from the tank. It could be from filling the case wrong. It could be anything. That's it. That's all there is to that.
That's it.
The clue to what was the cause of this failure is with that valve plate and the barrel. Those two parts looked like they bound together from a loss of lubrication, and they kind of grabbed and ripped off parts of each other. Loss of lubrication would have likely happened at startup. it means that they did not fill the case or they didn't fill it up properly. We know it wasn't a suction problem, or else that's what he was checking with the belling, and there'd be other signs, and that's normally we call that a case to inlet differential or poor suction characteristics. That has other warning signs that we did not see. So in this case here, poor startup. Parker is a leading manufacturer of hydraulic pumps and components. We're a distributor for them. It's our main business, and they just awarded us Distributor of the Year for 2 separate divisions. We're beaming with pride. We just got these Buy Hydraulics shirts in. Thank you so much for watching the whole video. Send us an email, sales@lifcohydraulics.com, with your address and size, and we're going to give a few out.